Good afternoon, everyone. My name is Jody Scott. I'm with Appretto. Previously, I was with the Arista Networks. I was with Arista for many years in networking. I've been in, before that was at Force 10. Been in networking for a long time and software development, and now with Appretto. Appretto is a startup based out of the Valley, out of San Jose, focused on workload segmentation and security. And so I'm going to be talking today a little bit about securing your workloads in AWS, and we kind of go from there. Before I kind of get started, I wanted to get let me get my audience, understand the audience. So can you guys let me know a little bit about where you guys are, from? Are you from networking, development, DevOps? What is the kind of any volunteers out here? DevOps. App development. Any networking people? Security management. Some networking people? No. Okay. All right. Mostly you guys are large companies, small companies, most large companies, mid companies, startups. Any startups as well? One startup? All right. Good. Okay. So one of the things that we need to obviously do is when we go into the cloud is we're going to want to secure our workloads. And so sort of the way to do this is if you're a hammer is all problems start to begin to look like nails. And so as a network guy, we kind of start to look at the way that AWS presents its security, its networking, and so on. And we try to take that and extrapolate that. So we kind of start with, I hope you guys don't mind if I kind of like start on the whiteboard, but we end up taking VPCs, and so we created our VPC, right? And then we'll put some virtual machines or something with someone within that VPC, and then we'll create a separate VPC, put our workloads over there, and then we'll have to get between those VPCs, of course, and so we'll deploy some type of virtual router, which is always this is now where we're getting to the point where if you're a hammer, all problems start to look like nails. Okay, so we're going to deploy this virtual router because we needed a physical router at one point to get packets physically from one thing to another. So I guess it makes sense that we need this virtual device to kind of get packets. So we create links and so on into this virtual router, and we start assigning our network, our non-overlapping address space. We assign this here, and we do the 10.10.11.0/24 here, what have you. Soon enough, we bring up a new VPC for another workload. We put some containers into that, or virtual machines. We add a new network on. We had to go back and check and make sure that we're not going to overlap with some other network or somewhere else. So we go with 17.0/24, what have you. Then someone tells us, of course, that we need to move we've got to further segment some of this. So we create a new VPC. We start migrating these into here. We give it a new network. Right? And we set up new route statements for this and that. And then someone says, okay, now we need to bring this all up at another AWS facility. So, okay, well, we just take it and we clone it somewhere else at another facility. We connect those. Then we go back and we find more IP address ranges and so on that are okay, so we won't have overlapping and so on. And we got to connect these together securely, so we create some type of tunneling between these two sites. Right, and then the management says, okay, now bring up another third facility. So now we repeat that whole process again. But now we've got to do that peering. But we've also got to do this peering, and now we've got this peering over here, and so on. And before long, a few things we start. They decide that these really should have been over here. So now inject a more a tighter seeder, so let's put in a /32 or /28 or whatever to override that, and starting to get complex, right? This is starting to get scary and so on. What we were trying to achieve, though, this is how we build out some network or something and so on, but this isn't what we were trying to just segment our workloads and create security and isolation. What we've got here is sort of a nightmare of complexity. It's very difficult to manage. It's very difficult to make changes. And I didn't even bring up the fact that management's going to come to you and say, oh, also we want to bring some stuff up at Azure as well. And their whole concept is different, right? So you're now going to have to go and learn a whole different type of setup and then tie that all back into here as well. it's becoming very much a nightmare to actually manage, to move, and so on. And then ultimately, we don't really have a high level of granularity of control within even within our VPC and so on. We may or may not really want these two containers to talk. Maybe we only want them to talk, during business hours. Maybe not after business hours and so on. So at App-Roto, we approached this problem and thought, let's start back over. We're not trying to solve a network problem. Let's make it simple. What if we just treated the network as one giant flat layer 3 network, okay? Everything could talk to everything theoretically. Just flatten it out. Doesn't matter if this is AWS, what facilities, Azure facilities, doesn't matter and so on. Just a big flat layer 3 network, okay? Now we have containers or processes and so on running inside of this, and we don't really care anymore, not perhaps where they're running, right? But now we want to talk and say, okay, well, these can talk to these, say, and these can talk to these. We want to start to kind of build those policies and so on. But we could try to build this on IP addresses, basically permit this IP address /32, match this port, and so on, as if it was 1970. But it's not 1970. It's 2018. We don't need to think in IP addresses anymore. Really, we don't need to. The IP address belongs at that layer 3. It's a mistake that it ever extended all the way up the stack anyway. There's really no reason we need to think that way anymore. How about we think in something like, I don't know, labels? So we could label our workloads like role equals web, and role equals database. And instead of building our policies based on IP address and permit this IP address to talk to this IP address, instead we say permit the web server to talk to the database server, or permit the database server to talk to another database server, right? And then we no longer had to worry about building out IP ACLs and having large, because of discontinuous blocks, large configurations and so on. We can greatly simplify it and just operate off this concept of tags. So that's what we've done at App-Roto. So before I kind of get into more, does this make, I hate to say does this make sense, but does this make sense? This is a problem that, does anybody actually hit what I had up here a second ago before I erased it? Is anybody hitting that? Is anybody trying to do that?
NetScout.
I'm sorry?
NetScout.
NetScout?
NetScout in the area is doing that.
Okay. Anyone else? No. Yeah. So a lot of times in compliance and so on, there's a requirement to segment workloads and so on. If we take this back to a traditional data center, we would have a north-south firewall, and we would have traffic going east. We have a lot of traffic east-west. We would not be normally traversing that firewall, and hence we would need to have the introduction of either a physical hardwares within physical firewalls within the east-west, or we try to build virtualized firewalls and say NSX or for virtualized Palo Alto or what have you between that traffic internal inside the east-west movement. So I'll start to talk a little bit about what we've done in App-Roto. And you guys feel free to ask me questions as I go along here.
Do you have to have a third-party product to implement this network concept, or can you do it with native AWS stuff?
So you can do it with native AWS. We have an open source library that we put out and so on to do this. And then we have our a commercial offering as well. Let me start the slideshow here. So at App-Roto, we set out to solve the security orchestration system for containers, APIs, serverless functions, and legacy applications. And so we wanted to basically talk about all the stuff that's, the Docker and the Kubernetes and so on. We wanted to solve that problem, but we also wanted to solve the legacy problem as well. And so what we do is we do layer 3 segmentation. And we've done this by modifying the TCP setup process to cryptographically exchange identity during the initial send, SYN-ACK, ACK phase. And so you guys are familiar with TCP. TCP does a 3-way handshake. It sends, SYN-ACK, ACK. What we do is we modify that to use TCP fast open, effectively, so that whenever the initial sender sends out the send packet, we include the tags that identify that particular process unit. And by the way, I use the word process unit because process unit encompasses both processes and containers. A container, is nothing but a process. We take the tags and we insert them into the initial send packet, cryptographically sign that packet, transmit it to the other side. The other side can then open it, remove the information, cryptographically validate that it came from where it came from, extract the tags, and execute a policy to say, do I want to talk to this other side? And if it doesn't, it simply drops the packet, and there is no setup. But if it does want to talk to the other side, it does a reverse process. It sends its identity and so on within the SYN-ACK packet back to the originator, who now has a SYN-ACK and does the exact reverse process, so they can determine, like, do I still want to talk to the other side? The information that we can pass along can be things like the vulnerabilities of the other side or say the system libraries. So if I initiated a connection to talk to someone, and I found out the other side was running an old version of glibc 2.20, I don't want to talk to you anymore. You should be running at least glibc 2.23. And I'm just going to simply drop the connection and stop talking to you. We can also do this to use transparent encryption. And transparent encryption based on policy. So one of the things we can do is, utilizing tags, we can actually say if the workload is running inside of a different AWS facilities, and so it goes between AWS facilities, transparently encrypt the flow. We don't need VPNs anymore. We don't need overlays. We don't need any of the complexity that was up here a minute ago. We don't need to worry about BGP. We don't need to set up route distribution, anything like that. And so we don't have to worry about ACLs. The other thing we do is we actually get into layer 4 as well, or layer 4 and up, and so on. So we actually within the URI, or in the operation of the API, and the API as well. We can talk about the tags. The tags I've been talking about, but I think a lot of the time is what exactly are these? And really, there's no limit to what these tags are. These tags or key values are just simply string. And so we can bring these identity in the form of, they can come in from anything. We will automatically, by default, start to bring it in. Let's say that you're running a process as a user, like if it's Jody on Linux and so on, I'm going to be running a process as Jody. We bring in that identity. We know that Jody, well, all the groups I'm a member of. We bring in things from your CI/CD pipelines or your orchestration platforms and so on. So your Docker swarms, your Kubernetes, your nomads, puppets, and OpenShift, Kubernetes, Mesosphere, and so on. We bring in all those products all have meta information or tags that we can consume to build policy upon. One of the great things about that AWS has done, and the other cloud providers are slowly catching up, is they provide you with a cryptographically signed document that, so if you're running from any virtual machine on any AMI running on AWS, you can reach out to a 169 address and do a REST call. They'll return a JSON object that's cryptographically signed by them that gives you all this information and so on about that. It tells you what that AMI's name is, the ID of it, the AWS facility that's running in, it provides this wealth of information back to us. We actually automatically consume this information and present it once again as tags so you can build policy. So you can actually build policy based on location. Like I said earlier, you could say if the flow goes between two different facilities, transparently encrypt it. But you can also build policy, say that if it's running inside the US, it's allowed to connect. If it's running in Europe, it would not be allowed to connect. We also bring in tags and key values from vulnerability scanning, things like Claire, or there's an open source thing that does vulnerability scanning of containers. But we can also bring in, really, there's no limitation with it. Anything that we can form into a string, we can bring that information in. And so from, say, Qualys or Tenable and so on, we can consume that information into the product and make that into tags that we can build policy upon. You can integrate with your your Oktas and your identity providers and so on. So I told you a little bit about the stuff like when we're running it inside here, but what about when we're running it when we don't control the outside the other party and so on? What about if it's not not us? They're not running our open source library, or they're not running our commercial offering and so on. We can identify them based on their, say, certificate or their OAuth 2 token and so on, using TLS and so on. So we will run TLS in front of it, and when the outside connects in, we can use their certificate to verify them. So we can integrate with your Okta or your whatever your identity provider is. So they authenticate with that. They come in to us, and we can use the same policy of labels to determine what are they allowed to access, what URI, if they're even allowed to connect, if they're allowed to access a certain URI, if they're allowed to do a post or a get. So think of it, you can actually say, this person is an employee of mine, they're allowed to access the employee directory. But they're not a member of HR, so they're not allowed to create a new user in the HR directory. This is all, there's no application rewrite necessary.
What's doing policy enforcement?
Sorry?
What's doing the policy enforcement?
So yeah, the way that we do policy enforcement is we are running we have an agent that runs on the host. And so the agent runs on the host, and it intercepts the sense and act, basically intercepts the initial part to set up the flow. And so when basically you look at like IP tables, except we're not doing like a long enforcement like IP tables matching on IP address. Instead, we simply say if a new flow, if there's not an existing entry for a flow, it's not marked, and it comes in, it sends it to AppRoto for handling. And that's when we do our exchange and so on, our verification and so on. Once we mark it, it's in the flows, and we can basically, you basically say that, hey, once it's basically authenticated and authorized, AppRoto gets out of the way. TCP simply takes care of the fact that the flow is now established and so on. And that's one way. And the other way is we get into higher level parts of the protocol and so on, we stay within the flow. Make sense? So we'll go back to like the IP addresses and so on. There's one of the things that really drove me nuts with the IP addresses and so on is overlapping address spacing and so on. It's been sort of you think about in a traditional IP ACL, you have somebody who's on a bounce box or something like that, right? So we have a box, a Linux box, and myself logs into it, I SSH'd into it, and another guy will say Miguel also SSHs into the same box and so on. Okay, this box has an IP address, I don't know, 172.16.1.1. And now we're going to basically go, from this we can SSH to anywhere else within the network. But if we want to build any policy on this, traditionally we would have to permit to say the 172.16 address. We can actually permit that or deny it. But once we collapse in on this box, we have the same identity as far as the traditional IP ACL-based firewall approach is. We cannot segment or segregate. We can't segment those or separate those. They're the same for us. AppRoto, since we're going to throw out the IP address and so on and go towards the label concept, Jody and Miguel are two different entities. We maintain that identity even as we head towards our next SSH session. So we can actually say Jody is allowed to SSH to certain things, but Miguel is not allowed to SSH to those or what have you. And it doesn't matter if this is a proxy or a load balancer or a bounce box or what have you. So as I was talking earlier, the way that we've done this, sort of the secret sauce, is to modify during the embryonic setup, to modify the packet during the exchange, so that when we have our application, and our application generates its normal piece, it has a socket, and it starts to generate its flow, this will cause a send packet to be generated. We intercept that packet, insert the information that into the packet, send it to the other side. The other side extracts that information, verifies it, takes out that information so that the packet is back to its normal self, regenerates the TCP checksum, and sends it into the application. So the application is none the wiser, has no knowledge that we've done this enforcement within the flow. Then the exact reverse happens. the other direction from the SYN ACK, and then finally the ACK. We also add a nonce exchange to prevent TCP replay attack. And finally, if we're going to do transparent encryption, we will also exchange AES keys as well. So as I was talking about earlier, there's the TLS. If we want to do TLS into Aperto and so on, we can take these. We can take the identifying of the application, like whatever this is the application on the internet that wants to connect to us, talk to us. And so it's going to come in with TLS and so on, and we're going to Aperto will handle the TLS until it hands off the application. And we can identify that remote by their certificate or token or what have you, so that we can give them identity. And once we have identity, we can utilize our tagging to determine whether or not we're going to talk to them or not. And then we do the vice versa, the reverse, where they make the call out towards a provider. Now, what's really neat about this is, rather than your traditional applications, let's say that you're using Salesforce. For instance, every application that you have, you would normally need to give that particular application identity or credentials from Salesforce, so that you could control and basically set up ABAC policies and so on within Salesforce to control that. Aperto can actually take it so that when the application goes to make the call to Salesforce, we will intercept, determine if that application is allowed to make that particular call, and if it is, we'll insert and inject the right credentials, and then they'll make the call on Salesforce. We're proxying it for you, so that there's no need for the application developers to actually have the secrets. And there's also no need to set up multiple different credential sets with Salesforce. We can just simply do one credential set because the application did not have access to it. So a different application that doesn't have the same privileges never actually had that credential set. It was injected by us and so on, so that you can treat them differently without having to maintain a different ABAC policy at Salesforce and every other third-party library that you interface, third-party API that you interface with. So I'm going to stop there and so on, and ask see if there's any questions. And,
So would you say, based on what you just indicated, that you would eliminate like SiteMinder things,
sorry, eliminate pings? Or?
the applications like SiteMinder and things like that that do single sign-on authentication, or is it just at the application layer? It's not
So we don't do single sign-on. We don't replace your single sign-on and so on. So that's so what we do, we integrate with those we're sort of a best believers and best for breed and so on. So we don't replace the single sign-ons and so on. Instead, those still continue to give you identity. We can make use of that identity to create effectively tags and so on. So basically, if you have your identity provider provides you with your OAuth 2 token, okay, now I can basically use that to determine who you are, your name, and so on, and that just simply creates tags and so on, or your organization, so I can create policy based on that. Anything else? Any other questions? We're going to start maybe doing a demo. Yeah?
How does it affect the actual security on the firewall level?
What do you mean?
Well, traditionally, you would need certain security between all the IPs and all that, right? And you said now you have a flat network.
Right. So what I'm actually suggesting and what I'm saying is that you don't need the firewall anymore. There is no firewall, at least internally, and there's no VPNs. There's no no overlay and so on. It's a very flat networks and so on. So for troubleshooting and so on, you can use ping and traceroute. You don't have to worry about IP within IP and MAC within MAC and all the overlays and so on. And the idea is to greatly simplify and simplify that and so on. And ultimately, your firewall is based on cryptography. Yeah.
Does that agent intercept all traffic, or just based on the policy that you set up for a specific application?
So it will intercept all it'll intercept all traffic, but and the one thing that's important to remember is that we're only going to intercept based on policy. Let's say the initial part of that. So will we add latency to the setup of the flow? Yes, we will. But it's only those first 3 packets, a few packets and so on. And then after that, if the policy says so, we're out of the way, and so there's no impact to that. So basically we amortize the cost of those 3 packets over billions or trillions of packets that get sent for the whole flow. We offer a commercial solution and an open source. You can find us open source on Trireme Lib. And on our open source commercial offering, we offer a software as a service platform where we run it as a software as a service. You don't have to run the backend orchestrator and so on. You just simply go in, log in, and access it directly. And there's an agent that installs on your Linux box and soon Windows. And if you're running Kubernetes and so on, it automatically deploys. It's a daemon set, so there's nothing you actually have to download or install. It's simply as part of the daemon set on deployment. All right. So what I'm going to do is I'm going to go ahead and make sure you guys can see that, sort of. I'm going to log in on the top frame here. I'm going to go ahead and I'm going to log into a box I have running on AWS. So I've logged in. It's a Bastion host. And now I'm also going to log in. So I'm logged into the same box. On the top is Jody, and below, I hope you guys can see it, is Miguel. And one of the, I'll do is I'll make FIFO, say temp x chmod temp x cat slash temp x and echo, hello. Redirect that to temp x. Okay, and you see it came on the front. So I am on the same box. So the point of that is to show you guys I'm on the same box. And I'll do an SSH to demo 1 here, and you can see I logged right in. But as Miguel, I'll do SSH to demo 1, and it's not going to go. And the reason is because we built policy. Policy, once again, you couldn't build policy based on IP ACLs in this situation. So based on my identity, I am, this is basically a demo we set up for the customer to basically demonstrate GDPR. And so the requirement here was, we've got people who log into a Bastion host. In other words, some of them are GDPR cleared, and by the way, I'm sorry, GDPR is the, I don't know if all you're familiar and so on. That's the European thing for data integrity for personal identity or something like, along those lines. Basically, what we wanted, this customer wanted certain people who are cleared to access GDPR servers are allowed to SSH to them, but people who are not allowed to SSH to those are not. And if you SSH to a GDPR server, you should not be able. If you SSH to a non-GDPR server, you should not be able to then SSH to a GDPR server, even if you're authorized to do it, because the data would be decrypted at one point during your SSH bounce. And so the idea here is that only people who are allowed to SSH into GDPR can, and they must go directly to the box. They can't bounce through a non-GDPR system and so on. And so we can actually even do a TCP dump. You can see that I'm trying to SSH as Miguel to the demo 1 box. I'm sending out send packets and so on, but I'm getting no response back. We have a UI that allows us to go in and see that here's me, and here I am SSHing into that server. And I can see that Miguel is not able to SSH in that server. Green means it was permitted. Red, get this, means it's denied. We can actually click on it and actually see the policy that allowed me, I was able to access it because I'm part of the sysadmin group. But I think a lot of you guys have probably dealt with this before, where you can't access something and you don't know why. Is it because it's just broken? Or is it because my security team's the firewall team's not allowing it? We basically believe that you should be able to know why something is basically not authorized. So Miguel can come in here and say, look, why am I being denied? Oh, I'm hitting this GDPR policy. Even though I would normally, I'm a sysadmin just like Jody, but I'm not able to allow that. Oh, I'm hitting this GDPR policy and so on that's preventing that. that was put in by a security operations team at a higher level, and I can't override that. You can also see, by the way, all these other SSH sessions here somewhere. That's the continuous, whenever I turn on something on Amazon and so on, I'm continuously, people are accessing, trying to access port 22 from all different all over the world. I can actually jump on that, look at that IP access, where else coming from, view the map, and see who's attacking me for whatever reason or something, where they're coming from. Questions? Yeah.
So I am struggling to understand how the tags are working and how you keep them so that they're unique.
Right. So they're not necessarily unique, because it's not about. What it's really about is that how do we know that anything how do we basically generate or create identity for anything? Like I'm Jody, but that's only my first name. That's really, and I can take my last name as well, Scott. That's also not necessarily unique as well. But it's ultimately it's about multiple different attributes. And if you get enough attributes together about me, you actually have uniqueness. There's only only me, one of me in the world. There's only one of you as well. We can get down to those attributes and identify that and create that uniqueness. But it doesn't. Remember that like a bunch of say containers or processes might be running in a cluster, and so basically your operations team labels them, say that this is application X, and then they say that basically let's allow application X to talk to application X. So anything that's labeled application X is allowed to talk to application X. Now, one of the things that comes up is like, well, if you were to have like app equals X, what about someone over here who did app equals X as well? Yes, but we can deal with that. We can use namespaces to deal with that. So then the concept of a namespace. So like a namespace is like something that you control all of that namespace, or your group does. And so anything that's in that namespace is something that you guys have set, and it won't overlap with something from someone else because it's qualified to the namespace. Questions, thoughts? Anything? Yeah.
So, we wanted to control traffic going from, say, our AWS into our internal networks, vice versa. How does that work? Can we label things that are custom within AWS?
Absolutely. So we actually operate above we're agnostic as ultimately as to where the workload is running. We're basically host to host, and so we're completely decoupled from the network. That was one of the major ideas and so on with that was to completely decouple from the network and also to become zero trust as well, but to decouple from the network. And so there's no, you can run inside your own data center. It can run on AWS. It can run on Azure. It can run on Google Compute. It can run on clouds that haven't been invented yet.
So if we're spinning up new instances internal, getting new IPs, how does that labeled IP association happen?
Well, for one, we don't have to think about IP addresses anymore at all. I mean, we ultimately, if you look at something and so on, you like to see that we do detect the IP address and create a label for that. But I challenge you, don't use that. Don't think of things in IPs anymore. It works. Try, and at first, I think that's a really hard thing for a while and so on. But as you start to think about it, you can get past it like that. We for a long time, we've thought of IP addresses as identity, and it never really was. We would deploy a server historically, and it would have a lifetime of 5 years or whatever it was, right? And we would give it an IP address, and that IP address was only its identity because we trusted the network, and because it kept that IP address for such a long time. Now in the world of containers or serverless, where something contains an IP address and then gives it back up within 6 or 7 seconds possibly, we can't basically establish an IP address and it's a long-term identity, but also we can't trust the network anymore because we've learned that lesson. We can't. Anybody who can obtain access to the network can emulate or pretend to be within that IP address range that we permitted. So when we do that, permit from 10.10.10.0/24, somebody comes into our data center, plugs into the switch or whatever and so on, boom, they're on that same local segment, they infect us. And we've seen the attacks become extremely sophisticated. Where we used to call it, when I was in college, it was the script kiddies, and so we call it, the stereotypical kid in the basement, guy in the basement, and so on. It's now very organized, very crime, and so on. And we've seen things like laptops that are infected by specialized viruses and just waiting for it to be taken into a data center, knowing when the attackers got on that laptop, they identified what company that laptop was with and infected it with a specific infection to cause it. Wait until they went back into the data center and patiently infect stuff that they plugged into the local adjacent segments.
So for most scenarios, if I don't need to know if they can only access during the day or whatever, why wouldn't you just use MATLS?
So mutual TLS, so certainly mutual TLS, there's a lot of value to mutual TLS, but there's a lot of ultimately limitations as to why mutual TLS. I mean, certainly there's this DSDO project and so on. There are a lot, but ultimately, we take a like sort of a at AppRunner we sort of take an agnostic and so on. We actually we'll integrate and manage it with DSDO and so on. But there ultimately are a lot of things. First of all, you take a major performance hit to do TLS is going to do a per packet, packetization, encryption, and so on. So you make a major performance hit. A lot of times you have traffic that's, say, internal, let's say iSCSI traffic or whatever have you and so on. There's no need to actually raise that to a level. You're basically, are you really willing to take that hit of an impact to the performance and so on? You might not. And so with AppRunner, we believe that, hey, it's ultimately about choice. Maybe you want to do a transparent encryption or that or TLS and so on, but maybe you're okay with it not being encrypted because of performance. And what you just want to do is authenticate and authorize the initial part of that, right? And so on. So like if you take like Istio and to scenario, they're going to use a sidecar concept on containers and so on. And ultimately what traffic is going to have to do is traffic is going to come into that sidecar, and then it's going to, so you're going to cross the kernel user lamp boundary, multiple context switches and so on, going to copy that memory into, and then you're going to send that packet back out to come back in the other container that's actually destined for, to go back out that container, back into the container and so on. So there's the high cost of that. We also, mutual TLS only allows, say, the exchanging of identity basically of the certificate, but not ultimately what we want to basically work on the concept. We believe in the concept of tiered attributes or multiple tags and so on. That just simply saying that, well, it's sort of the model with mutual TLS is sort of like, well, it's authorized because we can audit it and know that, like, yeah, it happened, but we want to go a little further in that it might never have been allowed to connect at all. Any other questions? The other thing we want to do is to capture other traffic, so on without necessarily requiring that it be modified. So like SSH, for instance, is not going to use TLS and so on. So we can take the SSH traffic, and we can also, one of the things we can do, I talked about a little bit, but is we can do transparent encryption on a per flow basis without any modification of the application. So if the application doesn't even do TLS or is not TLS capable, if it's IP capable, we can actually transparently encrypt that traffic and so on between between two process view containers. Any other questions? Oh, then I guess we're finished. Thank you, everyone.